So we're about to start a new and exciting chapter here at Vestas on the Isle of Wight. We're building our new V174 85 metre blade. It's got the latest materials and technology, and it's a culmination of 23 years of hard work and effort here at this facility. And what we're going to see is the journey of that blade, right through from raw materials through to finished product, then sending that over to Forley, our storage facility, and then onwards to North Sea projects that we are erecting today that are powering the grid, which is then powering our homes.
So there's three main stages of production of one of our wind turbine blades. The first stage is the mould stage. This is where we make the blades as we know it, using glass fibre and carbon. The second stage is finish and paint, to give it the look that we see on the turbine. The third stage is transportation and storage, where it sits until it's ready to be installed into wind farms and start generating electricity. Right now, we're mould side at the first stage of the blade build. The first thing that strikes you is probably the size of the mould. Offshore wind turbine blades are extremely big, and it's probably not apparent until you're right up next to the mould. The first main process we do is to apply the gel coat. This is to give us a smooth finish on the blade. So as we're rolling in the gel coat, there's another team that's coming behind, and they're starting to lay in the glass fibre, and we put in some other materials, including carbon, for strength. All of the materials are laid in dry, and then we apply a vacuum bag, and then we use atmospheric pressure to push resin through all of the glass fibre and the carbon and fully impregnate the structure. To cure that, we have to put insulation covers over the moulds, and we have to apply heat, and that will set the resin hard. We produce the blades in two halves of the mould, and then after the quality checks are complete, we'll apply glue, and the mould will actually close the two halves together and form the actual blade itself. On completion of the cure cycle, the mould will open again, and then we'll break the blade out of the moulds and we'll give birth to another blade there. Once that mould's opening and you can see that another blade, and you know what that means, you know, when that's going to be spinning on a turbine, it's really rewarding.
We are seeing huge growth within our industry. We're seeing a lot of changes in policies throughout the world, where a lot of governments now are looking to change from a reliance on fossil fuels over to renewables. And of course, the industry that we're in, we're supplying that to those governments, not just within Europe, but worldwide. So therefore, for us, we have to really sort of ramp up and develop our products here in order to meet those demands going forward. And what we're seeing is there's sort of a huge race that's going on amongst all of the suppliers going into that market. So for us to be as competitive as possible, making sure that we're right at the forefront of that technology, to be able to deliver into that market is a key thing, and we're doing that here on the Isle of Wight, and that's something that we are all hugely proud of, to be a part of that journey.
Here we are in Hall 2. This is our finishing and painting hall. This is the second part of our V174 blade manufacture.
They obviously finish the assembly side of the blade in the mould. It then comes out into our blade park. This blade then has to be rotated and brought into Hall 2. Once it comes into Hall 2, we then load our blades into the turners, which allows us just to manoeuvre the blade so we can get better access to where we need to shape the blade, trim the blade, sand it. The scanning process is one of the most critical, to be honest. The blade's being built, we've got these high technology scanners that can identify to the millimetre any issues. It's vital that obviously we get the quality right. Any sort of issues or quality defects will result in repair work, or potentially the blade won't be able to perform to its correct efficiency. So that's why it's vital to make sure obviously these scans are done. So once the blades conform to the right quality requirements, we then move the blade over into the paint element. We have teams with rollers rolling these blades. It's all time critical as well. So they have to work at quite a steady pace to get these blades painted. Our blades are obviously situated out at sea, so as you can imagine, they're open to the elements out there, which is why we have to put these coats of paint on it to protect it. It's really rewarding, obviously, knowing that we're a part of something that we're obviously producing these blades, and then these blades are going out to sea, obviously then generating renewable energy, which is obviously the future.
Welcome to Vestas Technology, where we design the wind turbines of the future. And these are the talented engineers and technicians that make it happen. Here at Vestas, we take a blade from concept through to design, development, and ultimately manufacture. The United Kingdom gets a quarter of its electricity from wind energy, and Vestas is really proud of the V174 that's going to safeguard the energy security and the low energy prices for the UK and other countries. And that's the culmination of years of effort of the engineers who have helped bring that technology from an idea into a product that we can manufacture. When you bring a wind turbine to market, you need to make sure that it's competitive, that it brings down the price of electricity, but also that it's reliable. And in order to do that, we have a range of engineers, really talented engineers and technicians who are analyzing the blade to make sure it's strong enough. Materials engineers who are ensuring that we have material innovations to keep pushing the forefronts of our technology and making sure we have secure supply chains. We have test engineers who make sure that the product is validated and the reliability is demonstrated. And we have manufacturing engineers who make sure that we can build them fast enough, but most critically, that we deliver the highest quality for our customers. That's really important, and that's what we do here.
Here we are at the third and final stage of our V174 journey. And this final process is all about delivery. So we've just seen the blade painted and finished. Once in the blade park, our next challenge is to move the blade over to the quayside where our transport boat will be waiting. It's a 75-metre barge. It's really cool. It's called Blade Runner 2, and it's the only barge long enough to be able to transport these blades. The barge then casts off, spins itself around 180 degrees, and is then escorted by the harbour master down the Medina and into the Solent. When you see the blade on the back of that barge, it just looks fantastic. The destination of the blade is just on the other side of the Solent in Forley, which is at the mouth of Southampton Water. Vestas have a storage facility there, and that's where the blade is going to be unloaded. Coming into Forley, Blade Runner does a 180 and reverses into the dock. It's quite narrow, so it's quite a tricky manoeuvre, and there the cranes and the team are waiting. Once the Blade Runner is parked, the cranes hook up to the blades on the root and the tip frame and unload it. From here, the blades are moved to Portsmouth before finally being shipped to the customer at the relevant project sites. And that's the full journey of our V174 blade, from start to finish, from raw materials to generating electricity in the North Sea.
This industry never stops still. Over the next 7 years, it's set to actually grow by 3 times. We are now putting ourselves so much at the forefront in this industry, and it's just a fantastic place to work, knowing that not only are you challenging yourself, but also what you're delivering back is also going to be helping globally. The future's looking bright here at Vestas. We are poised and we're ready with the world-class skills that we have here for the next generation, and we're very much looking forward to being a part of that journey.